Welcome, Josh. How are you doing?
Hello.
Hey, everyone. Looks like we have some people filtering in. So it is my pleasure to introduce Josh Lovejoy. He's held high profile roles at tech giants like Amazon, Microsoft, and Google. Frequently writes and speaks on AI design and ethics, where he is known for grounding AI in human needs. Today, he works at Prime Video, focusing on of AI for probabilistic systems. And earlier in his career, he architected Amazon's first unified design system for online shopping. So you are probably familiar with Josh's work here. So with that, I will leave it to you.
Thank you so much. Much appreciated, Christian. So thank you so much. I'm Josh. I'm a UX designer. I've been doing this weird UX thing for over 20 years now, but for the last 10 years or so, all in the space of machine intelligence. As mentioned, a bunch of it's been for these big companies like Google and Microsoft and Amazon, design of hardware systems and software systems, ethics frameworks, governance programs, policy, in all sorts of different fields and domains. But these slides are principally for the purpose of instilling a sense of credibility. We're not going to actually linger on many of these things. I may make reference to a couple of them in the future. But what I really want to do over the course of this time together is try to build a model. It's a model for us, about us, but I think it's exceptionally relevant for machine intelligence, and especially right now. It's a construct from logic called common knowledge. And the formal definition, which I'll flash up briefly, but then we're going to work through together, is that common knowledge is present in a group of agents when all agents know that they know that they know the same thing, right? Common knowledge of P, agents G. They all know P, they all know that they know P, and so on and so forth. Okay, so we're going to build this model sequentially, though, hopefully, so that it kind of resides and lingers a bit more in our collective unconscious. So we're talking about agents in human context. That means I, thou, self, other. So that's I know that you know, that I know that you know, that I know that you know. Okay, so what does that mean? Maybe when you're working on a project at work, and it's a huge difference maker if you know that I know that you know about what will obtain recognition from important stakeholders, the incentives that are aligned with promotion, recognition, so forth. If you don't know that I don't know that you don't know, then we have to play this game of figuring out, well, do we really know how to communicate this stuff? Do we know what will help us get ahead? Imagine you're trying to plan an outing with a friend or a colleague for going to a restaurant or something. If I don't know that you don't know that I don't know about something like a dietary restriction or a budgetary restriction, you get into all of this social awkwardness about how do you sort of like feel your way forward about what would be an appropriate suggestion that wouldn't be untoward, that would be inclusive, all of those things. When you're in a social gathering or maybe trying to meet somebody, it's a really important understanding about if I know that you know that I know about kind of the laws, the unspoken laws of interest and disinterest, right? If I'm saying something, if I'm flirting, if I'm trying to get your attention and you're totally disinterested, how can I signal that while knowing that that signal will be received, right? Okay, so there's all this stuff. We do it with ease, but I want to spend a moment to break that down even further, and then we're going to come back to the application in a technical sense. So common knowledge, right? It's not that there's just this perfect understanding, right? Because there's a layer of inference that exists between I and thou. I might act and you will receive. What does that mean, inference? It means there's a prediction layer, but actually it's not really a layer so much as a gap, right? Because something's happening unconsciously, something's happening in my brain space, then I'm choosing to express it somehow, linguistically or through my body language or whatever other form. And then it travels across space and time over into your sensory perception. And then the magic starts. Okay, so there's this gap. And when we talk about that gap, it is not just this one smooth conduit, right? There's the experiencing self, That's the self that comes from all of our past reference points, past situations, past lived experience. Then there's the choice, both conscious and unconscious, about how and what to express, in what form, in what manner, and then how it's perceived. And of course, it's bidirectional, right? So as hopefully my expression is received and perceived by you, then you experience that yourself. What do they mean? What's happening? In what situations have I lived in the past that have been similar enough that I can interpret this and then express back? And that's called feedback. And we all do this with ease. So again, humor the pedantic breakdown, if you will. Okay, so we go further. There's the experience, the expression, the perception that goes bidirectionally. But of course, it's not this like perfect wall. It's not like it just, I announce when it comes out and you announce when you receive it. It's this invisible, constant flow of signals. And it happens in so many levels, right? Again, like we talked about body language, context, mood, affect, tone of voice. And what makes matters more complex even is that the signal strength diminishes the further away it gets from my brain, right? When we experience something, we experience it with absolute salience. We feel those feelings, we absorb that past understanding, and then we try to figure out how to communicate it outwards. And so it's not this perfect signal strength. It's actually a weakened signal strength by the time it leaves our lips or our body emotes. And the same thing on the reception side, right? Signal strength only weakens as it travels through time and space, and then it's received on the other side. And it's not a nice, easy, everyone speaks the same language. It's like dialing into a radio frequency. Everything's modulated because, again, you might have had gotten bad news that morning, or woke up on the wrong side of the bed, or gotten great news, or eaten something that made you feel uncomfortable. Everything is weird, right? Life is messy. And it's also very unlikely that your experience, your past perception is going to perfectly line up with my experience, my past reference points. And so again, we've gone through this process of saying, well, it's not this perfect feedback loop that just engages harmoniously. Actually, it's this kind of amazing experience where we draw from our past, we bring forward outward to try to express something unconsciously, brain to brain. It's received, and then feedback comes out the other side. So this is where we're going to take a pause, because I know that was a lot. And it's also something that, again, we're so accustomed to doing interpersonally. And so why? Why are we talking about it? Why am I going through the process of breaking down this feedback loop? Well, it's because whether we like it or not, human beings cannot help but experience any computational system as a social actor. This is work that is well over 30 years old. At the time when it started, it was a test. A lot of the tests had to do with interactions with actual computer terminals. So people would take a training or some sort of like multifaceted course on a computer terminal or on multiple computer terminals. And then they would be asked to rate how effective the training was. And if they took the training on a single terminal versus multiple terminals, they were actually much more kind, generous, and forgiving if it was on a single terminal. Why? Because they didn't want to hurt its feelings. There's actually a built-up relationship. No matter what we do, any sufficiently complex system, we have to view as though it has feelings, emotions, idiosyncrasies, and so forth. People know, to be clear, that they're not interacting with a real living sentient agent. But again, we can't help it because we've got 200,000 years of firmware that we're operating with, right? Our mental modeling. I'm not talking about anthropomorphism. I'm not talking about, giving it arms and legs and a body and a voice, but I'm talking about theory of mind, right? This is how our species has gotten to where it's at. We find ways, and it starts so young, to project onto other systems a motive, a perspective, a feeling space, because that's our lens for interpretation. We do it with turn taking in preschool. We do it with our stuffed animals when we're young. We do it when we talk about our GPS not liking to take side roads, or we talk about how finicky or opinionated our tech might be. And this also goes the other way, right? And that's what makes this moment of machine intelligence so interesting, because we could talk about this as a generalized intelligence, but I like to think about it more as a strike against a belief in omniscience, right? Computerized systems, computational systems are about predicted believability. They're about running through a neural network, just like what we talked about with past reference data and projected outputs. And what makes them work is that they actually have to do a form of perspective taking. Next word prediction or sequence prediction is itself a classification of believability, right? What is most likely to be believed? That's what a loss function is doing in an LLM. So we've gone through this process. We've built this mental model together about self and others in a human-to-human context. We've now said, okay, actually people perceive computerized systems as a social actor, not an anthropomorphist, but as a thing with a theory of mind attached to it. So we can actually relabel these as human and AI, or human and agent. And why is that helpful? Well, because again, we know about all the signal laws, about the mismatches that are in place. So now we can attach two more layers on top of this. One are the bias layers, right? This is about how on our side, we can't help but both perceive these as social actors, but also as objective social actors, computerized systems, because they're operating from data, from statistics. We have a propensity to believe that they are more objective than perhaps they are. And of course, that reference data is chosen by people. The people who train, build, fine tune these models, they are the ones that get to choose where to point the model at in order to derive patterns. And then on the other side, as it travels backwards, we also have the choices about how we provide an optimization function for the model, what it's attuned to be able to do, right? If believability is one step, what happens when it doesn't know? What happens when the input from the human is mismatched with the reference data? Is the model allowed to communicate? Is the agent allowed to communicate its ignorance? That's on us to figure out if that's aligned with the optimization function. Because again, on the other side, on the recipient side, we also are predisposed to confirmation bias, to believe in our own sensory perception, because how could we not? So this is the full model. And I'm going to give a couple practical examples in our milieu, and then try to bring it back around. But we've built this together. I hope it's making sense. So when we think about, let's say, a search query context, right? Somebody enters the word physicist into an image search. Do they have common knowledge? Do they know if they have common knowledge? Well, the optimization is likely going to point towards a fill in the blank, like most referenced physicists, right? That's the expectation of intent. That's the interpretation layer that happened in that inference gap between, right? But what if that's actually not my intent? What if I'm a young girl who's looking up what can a physicist look like, and I've just typed in physicist and I receive a bank of mostly older dudes? Is that aligned with my common knowledge? Well, probably not. But again, what do we do about that? Well, then there's speech recognition. And in speech recognition, I like to think about this in a sort of a couple different axes. The things that should affect accuracy are the things that shouldn't affect accuracy. And which of those are independent of perspective taking, of theory of mind, of common knowledge, right? And which of those are dependent on a perspective. So for example, gender identity, accents, and age, we should be able to agree that shouldn't affect inaccuracy. Whereas maybe the speed that one speaks, or the pitch or pauses that one takes, well, hopefully that also shouldn't affect inaccuracy. But the difference in all of these things is, how does the system and I know, how do we calibrate what we mean by an accent? Everyone has an accent. It just depends on where you grew up, on whether you perceive that as an accent. Whereas words per minute is something that's much more objective. On the flip side, things that should affect accuracy, well, interruptions and unfamiliar words and perhaps enunciation, those things should affect, but again, who's to say what is an interruption? There's huge cultural differences about when an interruption is and is not appropriate, versus something like proximity to microphone or the decibel level of speech. Those are things that are much more objective and should affect accuracy. So again, these are all things that are designable, but we have to be able to distinguish between where the common knowledge needs to reside between the computer and the user versus where we can actually encode those characteristics into the optimization. Is a camera I worked on several years back that's like an autonomous self-driving camera. And the question there is, what does it mean for something to be candid, memorable, delightful, meaningful? And so on the left side, we needed to design systems that actually allowed a starting point. Hey, here's what we believe to be a great, memorable single frame, but then allowed the user to go in and fine tune the specific frame or perhaps the boundary edges of a little clip or snip. On the right side, we actually allowed this toggle flip to sort of look below the cut line. What did the camera find just close to interesting, but not interesting enough to curate? And so by flipping that switch, it allows the user and the agent to start building a set of common knowledge and common understanding. There's a connected store system that I worked on at Microsoft that believes to help, intends to help with things like inventory management or shelf stocking. But so often people were placing their cameras in ways that were way above or aside or not in view of the actual calibrated computer vision understanding. And so we built this really important onboarding system that allowed you to see through the eyes of the AI, essentially. It projected an optical field, an optical flow field, on where it thought the perspective line of the floor was. And then you could drag and move and manipulate that, or maybe you find out that you need to move the camera itself. So much better to do this up front rather than wait until there's massive errors. And then lastly, when working at my last stint at Google, thinking about how search could become more personalized and more generative, there's massive gaps there in something like, meal planning. Well, we could actually do some really interesting stuff to say, let's project outward a couple of these recipes on the left side, and then the kind of characteristics of those recipes to see first and foremost, are these aligned with your understanding of what those recipes feel and taste like? And then once you've done that, can you actually press on those and build in the reverse on what could be hearty and umami in this instance, and then save it as a bank of suggestions. On the right side, the idea here was to be able to cluster and sort these different facets of your past queries so that when you're performing a search, you can see an unpersonalized set and a personalized set and be able to actually introspect into what the system thought. When you say meal planning, it's actually like there's a facet of you that has to do with your family and affordability and all this other stuff. And then you can go and introspect on that and decide if you want to edit, delete, or otherwise. All these are just a couple quick examples, but all of it is to say, please try to retain this mental model, right? Please try to understand that the instantiation of a relationship between a human and an agent begins with a mismatch. It does not begin with perfect alignment. And as long as you can start with that it begins with a mismatch, then you can work and say, let's do the interesting work of forming common knowledge together. Thank you.
Great. Thanks so much, Josh. I really love how you built that up for us. That was a really cool presentation. You're getting a lot of love in the chat. A lot of interesting thoughts sparked. If you guys have a quick question for Josh, let me know. But I will ask one about, I like this one on feedback loops. When feedback loops reinforce perceived accuracy, how do you distinguish between legitimate adaptation and socially reinforced bias? Maybe a tough one, but
yeah, it's a good one for
it's
a quick one.
Yeah, right.
So I think the shortest answer to that is to build for what I call multi-turn interactions, which is to try to avoid the system producing a single right answer, but instead, in situations where you believe there may be sort of socially imposed or inculcated biases or mismatches between what is commonly or conventionally understood versus individually interpreted, instead of responding back with a single perfect answer, respond back with a bank of potential avenues to explore. And
Nailed it.
let the user decide. Right? Give them a little bit of a choose your own adventure.
I gave you a juicy one, so thanks for the quick answer there.
Yeah.
And thanks again Really awesome visual story.
Cool. Thanks so much for having me.
All right, Josh, thanks so much.
Cheers.